let's quickly go to the AGO. Again, very brief revision. Then we'll practice the same topic that we did yesterday. As I told you that during these days, we'll be doing masses, masses, and masses. Okay? So, whatever we have done, you can see on the screen. All right. Brief revision. We have calculated the masses like H2SO4, vertical method. This, on the right side, you can see the atomic masses. A short assignment was given to you. I hope that you have done. I've received most of the assignment. It was wonderfully done. That's wonderful. Whoever submitted the assignment, thumbs up. Anyway, so H2SO4. How we found? How many hydrogens? What is the atomic mass of hydrogen? 1. In sulfuric acid, how many hydrogens? 2. That is why I multiplied 1 by 2. 1 2s are 2. Next is sulfur. S. 32. How many sulfurs? 1. How can you find that there is only one sulfur? Because there isn't any subscript. Subscript means the very small number written at the bottom. That is called subscript. So there isn't any subscript written there. It means 1 is there. So 32 ones are 32. All right. Then the next is oxygen. Atomic mass of oxygen is 16. How many oxygen do we have as a subscript? 4. 16 for the 64, and you got the answer 98. All right. Then horizontal method, the same, but in a different way. H2, SO4. All right. Atomic masses, we did it. I'm not wasting the time on this revision because the time is already gone. This was all that mass is the sum of protons and neutrons. The second point is one single atom is so small that we can't find its mass by ordinary method. That is why scientists chosen carbon-12 to find out the masses of the other atoms, right? And they divided all the mass of carbon into 12 parts. Each part they called 1 AMU. I know it's confusing. So all the masses that we hear, like the mass of oxygen 16, like the mass of chlorine is 35.5, like the mass of sodium is 23. These are all the compared masses. We have compared these masses with 1/12 of the mass of carbon. Anyway, so this is very basic, fundamental, most important topic of chemistry. Like calcium phosphate, Ca3, PO4, 2. It's a compound. Calcium phosphate. What is the difference? Here you can see a bracket. First of all, we should know the masses of these atomic masses. So writing here, the atomic mass of calcium is 40. It will be given to you, 40 AMU. What is the atomic mass of phosphorus? 31. Oxygen 16. So these masses will be given to you. All right. So we'll use this. Okay. First is calcium. I'm writing here Ca. What is the atomic mass of 1 calcium? 40. I'll write here 40. What is the subscript here? How many calciums do we have? 3. So we multiply it by 3. Why 3? Because here we have 3 calciums. Multiplying, it will give you 120. Next, phosphorus. Now phosphorus or P is inside the bracket. So whenever you see an element inside the bracket, you have to consider the number which is written outside the bracket. Okay? Now one more question. What is the subscript? How many phosphorus do we have here? No number is written. That is why we consider here that is 1 written here. Supposed 1 is written here. All right. So if someone asks, what is the value of P over here in terms of masses? You will write what is the value of 1 phosphorus? 31. How many phosphorus? 1. You have to multiply this subscript by this one. 1, 2 is 2. Right? Next is oxygen. Mass of single oxygen is 16. How many oxygens? Again, we have a subscript 4. We should multiply by this. So what should I write here? 4, 2 is 8. Okay, so 16 8s are 128. All right. Now adding all of these, so 310 AMU would be its mass, molar mass. Okay, repeating, calcium 40. How many calciums? 3. 43 is 120. Phosphorus 31. How many phosphorus? Here we have a number, a hidden number 1. 1 2 is 2. 62. Oxygen 16. 2 4 is 8. 16 8 is 28. Adding all, we'll get 310. Clear? See another example of the same type of problem. Magnesium bicarbonate. All right. So the masses of atomic masses of magnesium 24, hydrogen 1, carbon 12, oxygen 16. It will be given to you. All right. Let's start. Magnesium. What is the mass of 1 magnesium? 24, I told you. How many magnesium do we have here? Just 1. Next, hydrogen. Mass of 1 hydrogen, 1. How many hydrogen do we have here? What is the subscript here? 1. It should be multiplied by 2. 1, 2 is 2. I'm a little bit slower this time because I'm trying to convey it you effectively. Carbon 12. How many carbons? 1, 2 is 2. 24. Next, oxygen, 16. How many oxygens? Who will tell me? Right. 3 2s are 6. I should write here 6. Okay. Now adding all of these, you will get what? 146 AMU. So these are the two examples. Check it. After seeing these two examples, now you will solve the remaining 4 parts of the assignment as practice. Okay? Clear? You can take the screenshot of that one also. Done? All right. After this, there's a little bit explanation of few definitions. Then the class would be over. And all clear? Okay. See, I told you what do you mean by a molecule? When 2 or more than 2 atoms combine, they form a molecule. Like the molecule of water, H2, like the molecule of carbon dioxide, CO2, like the molecule of sulfuric acid, H2SO4, like the molecule of sugar, C12, H22O11, like a molecule of glucose, C6, H12O6, like a molecule of nitric acid, it's not nitric acid, HNO3, and so on. All of these are the examples of molecules. Remember, molecules are not everywhere. A term that we will use in the upcoming chapters, chapter number 4, 5, chemical bond. In molecules, what happens? Atoms share their electrons. Suppose this is one atom, this is another atom. These two atoms will create a partnership, a mutual partnership. They share their electrons. They will be together. Sharing occurs. When sharing occurs, molecules form. When sharing occurs, molecules form. And this type of sharing you will study afterwards. This type of sharing is called covalent bond. So what is covalent bond? It's a bond, it's an attractive force in which atoms share their electrons. Suppose there are two little kids, they are sharing their pocket money to buy something from the tuck shop. It means they are forming a covalent bond. Okay? Sharing, covalent bond, molecules are there. Okay? Second, there are compounds, many compounds, thousands of compounds, in which no sharing occurs. When sharing is not occurring, what else? In such compounds, transference of electrons occur. Suppose this is one atom and this is its electron. Okay, this is one atom, this is electron. Mostly this atom is a metal. Okay, so metals have the ability to donate its electron. So if this is a metal like sodium, it is its electron, then this metal atom can give this its electron to the other non-metal atom. This metal atom has lost electron. This non-metal atom gained electron. Losing, gaining, transference. This type of bond, this type of linkage is called ionic bond. And in such compounds, what is point to be noted? In such compounds, there isn't any formation of molecule. Okay? No molecule is formed in ionic compounds, in those compounds in which transference of electron occur. So what is the bottom line here? What is the summary here? That if the sharing of electrons are there, a molecule is formed. Okay? And sharing occurs between non-metal and non-metal. You should go through all of these from the YouTube channel so that you will be able to understand it easily. Second, if one is metal, other is non-metal, then metal will donate its electron, will give its electron to the other one. This type of bond is called ionic bond, and in ionic bond there isn't any formation of molecule. Okay, so what have you just studied? A molecule is formed when sharing occurs. Okay, okay. So if a molecule is formed like water, like sulfuric acid, then the mass of that molecule is called molecular mass. Molecule is there, its mass is called molecular mass. Like the water or carbon dioxide, its mass is 44, we can find it out. We have just found out the molecular mass. Yesterday we have found the molecular mass of glucose, it's 180. The molecular mass of sulfuric acid, 98. All right. Now what about those compounds in which there isn't any formation of molecule? For ionic compounds, for ionic compounds, if we write here molecular mass, then this will be 100% wrong, because in such cases there isn't any formation of molecule, so we can't say its mass as molecular mass. Okay, so there they use a term that is called formula mass. Formula mass is not only for ionic compound but also for ionic compounds. For example, this is water, molecular mass. This is sodium chloride, ionic. Okay? What will we call its mass? Molecular mass. We can't say its mass as molecular mass because it is a ionic compound. So what else we call it? We call it formula mass. Remember, formula mass we can use not only for this but also for this. So at somewhere you will see that molecular mass. Now the point Whenever it is asked molecular mass, to find molecular mass, you will write answer in AMU. For molecular mass, the answer is AMU. But if you don't write AMU, you will write grams, then it will be called molar mass. So if you see the definition of molar mass, a mass which is expressed in gram. So we have done so many masses. We are all are confused. So scientists found a very simple solution of it. All of these are written in your book. All of these are written in your book. And inshallah, I will try to explain it again on Monday, because I know it's quite confusing. What they did, suppose if I write atomic mass of carbon is 12, fine, AMU. Molecular mass of sulfuric acid, H2SO4, we did it, 98 AMU. And formula mass of NaCl, just add them, 58.5 AMU. Different type of masses are there. So scientists say, instead of writing so many masses, just write a term, molar mass. And write, instead of AMU, write G, grams. It means it is correct to say atomic mass of carbon, or you can also say molar mass of carbon. It is correct to say molecular mass of sulfuric acid, or you can say molar mass of sulfuric acid. It is correct to say the formula mass of sodium NaCl is 58.5, or you can say the molar mass of NaCl is 58.5. So what is the definition of molar mass? What is the definition of molar mass? Atomic mass, molecular mass, formula mass. When expressed, when written in grams, it is called its molar mass. Molar mass means in grams. I repeat, what is the definition of molar mass? You can see in your book that if you express atomic mass, molecular mass, or formula mass in terms of gram, it will be called molar mass. Okay? So, what is the main point here? That instead of using different kind of masses, they use a single term, molar mass, in grams. Rest of the things are just at 1.5 line or 1 line definitions. Okay? So what is the next topic? We'll still practice it more, and you will see the questions from the exercise of chapter number 2 I will solve on the board. So all of these definitions are written in your book. Go through the book and see what is there, what is not there, and what else. What else? Next is, again, it's very simple topic. The next topic, that is the next second half of Monday's class probably. That will be the molecular formula and empirical formula. What are you going to do? Practice the assignment that I have given to you. That one, 6 parts you have done as an assignment and send it to me. If you have not sent, just send it. The next 4 like these, the different one, the bracket ones, you are just solving it for yourself. If you have any question, you can ask in the group. You can email it to me. Okay? And what is the assignment here? See question number 1 to 4. All of these are general questions. These are not the usual questions. At times, something that you have listened during the lecture means you have to go through the Google. You have to Google it by yourself. It's simple. You can cover it within 5 minutes. It's a 5 to 7 minute assignment. Hardly. You are not going to write so many paragraphs. No, at all. Okay. About question number 4, just mention. Let me remind you a few things. For question number 4 of the assignment, the hint. See, there is a periodic table. We have a group, 1A group. Its members are lithium, hydrogen we do not include. Lithium, sodium, potassium, rubidium, cesium, and francium. Okay? There's another group beside it. It's called 2A group. Its members are beryllium, magnesium, calcium, strontium, barium, and radium. These are those metals which donate electrons. Means they have the habit to give electrons. So they form ionic bond. They do not form molecules. How can you identify that which one is forming molecule and which one is not forming molecule? If you see any one element from these in a compound, you say, oh, it's not a molecular compound. It's an ionic compound. I repeat, these are the 2 groups of the periodic table. They have the habit to donate electrons, means they always form ionic bond, right? They give electron. So when they give electron, molecules will not form. So it means whenever you see these elements in the compound, for example, if I ask, is this a molecular compound or ionic compound? You say, oh, potassium is here. Sir, it's an ionic compound. If I say, it's molecular mass, sir, you don't know chemistry. It's not a molecule. You can't say it. It's not, its mass is not, it can't be called molecular mass. It should be called either formula mass or molar mass. So in question number 4, you have to only identify that for which you can use molecular mass and for which you can't use the term molecular mass. And if you are responsible enough, intelligent enough, then you can find out. It will be just for your own self. You can find out the molecular masses of these, the molar masses of these compounds just for yourself. That's all for today. Okay. Thank you so much. Allah Hafiz. Have a nice weekend.